Okay, this video is looking at features of science. What makes science science, and is psychology a science? So this video is going to describe key features and assumptions of scientific inquiry. And we're going to be looking at what extent psychology as a social science meets this criteria compared to other natural sciences like physics and chemistry. So features of science appears on the AQA specification under features of science in research methods, but it's really important throughout the whole course. So particularly when you're considering the quality of evidence, using research methods to evaluate a particular study, you need to be able to consider whether it's scientific and in what ways it could be improved to be more scientific. And features of science is also really important in the paper 2, the approaches in psychology. So here we're going to be considering the emergence of psychology as a science, and we're going to be considering whether particular fields within psychology are or are not scientific. So it's important that you know what the features of science are in order to make those determinations. So let's have a look at what the features of science are. You'll need to know clear definitions and explanations of each of these terms. So we're going to be looking at objectivity and empiricism and empirical methods, the idea of replicability and falsifiability, theories and theory construction, hypothesis testing, and paradigms and paradigm shifts. So lots of new vocab for you there, but we'll be going through each of these in detail. So I just want to remind you of the scientific method, and the way that we come to define knowledge, really, and discover knowledge. I want to remind you that science is a verb. It's not a noun. It's an active process. Science is doing. And there's no end point. So this is why you see it here as a bit of a wheel, because it's constantly being revised. Scientists are constantly revising theories and ideas based on new observable evidence. There is no end point. It's constantly evolving. Scientists begin by defining the question. They start by pondering and wondering, I wonder if, what happens when? And they go from these observations and these questions, they gather more information so they can form hypotheses. They then test these hypotheses and analyse the data that they obtain from their tests. They interpret that data and then they publish their results, and it's out there in the scientific community. Then they or other scientists will retest this finding in other contexts and other circumstances, and it will constantly be revised until the theory is strengthened. So let's have a look at each of these features of science. The first is objectivity. Early empiricists, like John Locke, thought knowledge was determined only by experience and sensory perception, and he believed that this was true for all sciences. And this will include psychology. So researchers must strive to maintain objectivity as part of their investigations. So this means that they need to keep a critical distance during the research, so they don't allow their personal opinions or biases to discolour the data they collect or to influence the behaviour of the participants they're studying. So it means taking a step back and being a little bit removed from your investigation to avoid imparting bias upon it. Objectivity is the basis for empiricism and the empirical method. So empiricism, that word derives from the Greek word for experience, and this emphasises the importance of data that's collected based on direct sensory experience, not personal viewpoint or opinion. Generally, the experimental method and observational method are good examples of empiricism in psychology, and generally the research methods that have the greatest level of control, so for us that's lab experiments, tend to be the most objective. They tend to be the ones that allow for the least amount of subjectivity, personal opinion, and bias. All right, replicability is the second feature of science that we need to look at. And replicability is the extent to which scientific procedures and findings can be repeated by other researchers. So if a scientific theory is to be trusted, the findings must be shown to be repeatable across a number of different contexts and circumstances. If something is true, it must always be true, no matter where, no matter when, no matter with whom. So replicability involves repeating a study in the exact same way to check the reliability of the method and also to verify the validity of the findings. So replicability has an important role to play in assessing the validity of a finding, and it allows us to ask ourselves, to what extent are the findings true? Are the findings robust? Are they true in different contexts and different circumstances? And to what extent can we generalise these findings with different people under different circumstances? Replication also allows for the recognition of errors in research. The likelihood of the findings occurring twice by chance alone, and not due to the manipulation of your IV, are much smaller than when they occur the first time. So in other words, flukes do happen in research. Sometimes you find something that seems significant when it's actually not true. And that happens. But it doesn't often happen twice. And so if we can repeat the procedure exactly, and we find the same thing twice, it's much less likely to be by chance. It's much less likely to be a fluke. So that increases our trust in those findings and the validity of those findings. In order for replication to be possible, it's essential that researchers report their investigation with as much precision and rigor as possible, so that other researchers can verify their work and verify the findings that they've established. So this is why we emphasize standardized instructions and procedures and operationalized variables. They're so important because it means that the researchers can clearly communicate the procedure of their study to other researchers who can then repeat it exactly and hopefully establish the reliability of the findings. So replication is a really important feature of science, particularly in psychology. All right, the third feature of science is falsifiability. Karl Popper, he was a philosopher of science, and he argued that the key criterion of a scientific theory is its falsifiability. Genuine scientific theories, he argued, and hypotheses must hold themselves up to hypothesis testing. It must be empirically testable to see if that theory is false. In other words, it must be possible to prove a theory false. No matter how many positive validations of a theory occur, no matter how much evidence you find that a theory is true, it is never undeniably true. It doesn't prove that the phenomenon is undeniably true. All it shows is that the theory hasn't been proven false yet. So Popper illustrated this through a really famous parable now of the black swan, hence the images on your screen. So suppose a theory proposes that all swans are white. The obvious way to prove the theory is to check every single swan really is white. But there's a bit of a problem, because no matter how many white swans you find, 100, 1,000, 1,000,000, you can never be sure that there isn't a black swan lurking somewhere around the corner. So you can never prove that this theory is true. In contrast, all you need to do is just find one solitary black swan that would guarantee your theory is false. And that's the power of falsification. And that, Popper argued, should be the aim of science. The ability to disprove a theory with just a single example. So we should not be seeking to prove a theory true. We should be seeking to prove a theory false. Any good theory and good science should be able to be challenged. So we should be able to prove that theory false. This is why we never say in psychology, this proves. Instead, we use phrases like this suggests or this seems to support, because nothing is ever proven. All it would take would just be one single example to disprove that theory. So this suggests, this seems to support, and never this proves. And this is also why in any investigation, we provide a null hypothesis alongside a research hypothesis. So if you remember back to our very first research methods lessons, a null hypothesis is one that says that there is no effect. So in this case, the null hypothesis would be that not all swans are white. So the theories that survive the most attempts to falsify them become the strongest. So this isn't just because they're necessarily true. This is because despite the best efforts by researchers, they haven't been able to be proven false yet. So the process of falsification is achieved via replication. So we test a theory under different circumstances to try and prove that theory false. So the more failed attempts to falsify the theory, the stronger that theory is. And this is how Popper was able to draw a line between true science and pseudoscience, or fake science. So pseudoscience consists of beliefs or practices that are claimed to be scientific and factual, but are actually incompatible with the scientific method because they can't be falsified. So if you take, for example, detox programs that remove toxins from your body via coffee enemas or these pads that are attached to the bottom of your foot overnight. So the marketers of these detox programs They talk a lot about these toxins that are mysterious waste products of a Western indulgent lifestyle, but they never actually define what they mean by a toxin. And because they don't define a toxin, this therefore can't be empirically tested by scientists, and therefore we can never prove the existence of toxins false. Therefore, we can never prove that detox programs don't work. And this is why they've been around for so long and are a billion-dollar industry. They are not scientific because they don't hold themselves up to scrutiny, and they cannot be falsified. We cannot prove them to be false. So Popper's argument is essentially that it's really easy to find confirmation of a theory if you're looking for it. So we shouldn't be looking for confirmation of a theory. Instead, we should be looking to prove the theory false. We should be trying to falsify it. If a theory can't be proven false, then the theory is strengthened. It becomes a stronger theory. And he often gives the example of like the existence of Santa Claus. If you're seeking to prove the existence of Santa Claus, you're going to find it. It's easy to prove that he's real. You see him in the mall, you see him on TV, you see him hanging from Christmas trees all around the world. It's really easy to find existence of Santa and to prove that he is real. So we shouldn't be seeking to do this. What we should be doing instead is to prove that he isn't real. So this would involve staying up on Christmas Eve and pulling on Santa's beard to see that it's actually your next door neighbour or your father. So by only being unable to disprove the theory, so unable to falsify the theory, can we accept it as true? And this should be the aim of science, is not to prove a theory true, but to try and prove a theory false. And if it can't be proven false, then that theory is strengthened. So, let's have a look then at theory construction and hypothesis testing. So science is all about testing theories. A theory is a set of general laws and principles that can be explained by various events or behaviours. We construct a theory by gathering empirical evidence. So theory construction occurs by gathering evidence based on direct observation. We go from having a hunch about something to forming a testable hypothesis, to then conducting a study to test that hypothesis, to then draw conclusions, and then propose our theory. And we should be able to make precise predictions and hypotheses based on that theory. So if a theory is true, then we should expect to see X happen when we test it. So we should be able to make predictions on the basis of that theory. These theories must be scientifically tested using objective methods. So using scientific methods like an experiment or an observation, we should be able to either support that theory or refute it. So hypothesis testing allows the theory to be either strengthened, or if our evidence doesn't support that theory, we need to go back and revise it. We can either use inductive reasoning, which is a scientific process that I've just explained, or we could use deduction, which involves deriving new hypotheses from an existing theory. So constantly testing the theory of relativity in different circumstances, for example. All right, we're now moving on to look at paradigms and paradigm shifts. So what distinguishes scientific disciplines from non-scientific disciplines is paradigms. And these are a shared set of assumptions and methods. So it's been suggested that social sciences, so including psychology, lack a universally accepted paradigm. And are probably and sometimes described as pre-science or as a series of mini paradigms. And these are distinct from natural sciences like biology and physics. So natural sciences, let's take biology for example, they have a number of principles at their core. So in biology, we've got the theory of evolution, and we've got the standard model of the universe in physics. However, in psychology, we don't have one single unifying shared assumption or agreed upon method. Psychology is marked by too much internal disagreement. You've got too many different psychologists interested in studying different aspects of human behaviour, and they've got conflicting approaches. And therefore, it's considered by some to be a pre-science in need of a revolution in order to unify the study of the mind and come up with a consistent paradigm. So this is called a paradigm shift. And this is when a handful of researchers begin to question the currently accepted paradigm, critique begins to gather. It's a bit like minority influence, and eventually a paradigm shift occurs, which is a significant change in the dominant theory of a science. So this happened in physics when they went from Newtonian paradigm to Einstein's theory of relativity, and it's happened in all of the natural sciences. But it's yet to happen in psychology. We haven't had that big paradigm shift where we've had that significant change in the dominant theory. So this is why psychology is argued by some to be a pre-science in need of that big revolution. So scientific advancements don't just happen bit by bit by a steady progress, but revolutionary paradigm shifts happen as well. So big significant changes also happen in scientific advancement. All right, so to sum up the features of science. So you need to know each of these features of science in order to determine, when we're looking at the approaches in psychology, which approaches are or are not scientific, and to be able to articulate why that is. It's important to know the features of science so that when you're shown a new study that you've never come across before, you can determine if they are or are not scientific and how and why. And then for those new studies, you can provide suggestions for improvement of how to make them a little bit more scientific. So we're going to be looking at examples of pieces of research that either are or are not considered scientific and why that might be. And that's a really important skill for you for research methods. So in order to do that, in order to determine whether a study is scientific, we need to ask ourselves questions such as, is it objective? So has the researcher obtained quantitative data? Is that data able to be inferentially and statistically tested? Have they randomly sampled their participants, or was there bias in the selection of participants? And has that researcher maintained a critical distance? So by employing a double-blind procedure, for example. We need to ask ourselves, can the study be replicated? So have there been really clearly standardized instructions and procedures used, and have they been communicated effectively? Have the variables been operationalized so that we can repeat that study exactly to see if the findings withstand? And is replication possible in other contexts? Could we take this study and complete it in a different context or with different circumstances or a different sample of participants? And are we likely to see the same findings? And we need to ask ourselves whether the scientific method has been followed. So has the researcher gathered evidence based on direct observation and experience, i.e. is the data empirical? So these are some of the questions we need to ask ourselves in order to determine whether a study is scientific. Sorry, I've got that on the screen now. Sorry about that. And this will be an important skill for all of your research methods. So not only do we need to know the features of science for the approaches to determine which approaches are or are not scientific, but we need to be able to apply these terms to novel and new research studies as well.